Okay, so we have seen about the basics of cascading common emitter amplifier in the last class. So now we are going to see in a single stage common emitter amplifier what effect is going to happen because of this capacitance CE and RE in the circuit. So we are going to see what is the effect of this capacitance CE and the coupling capacitance on the frequency response of my common emitter amplifier. So in all common emitter amplifier circuits, this is the standard circuit we are going to follow. We are going to have voltage divided bias, and input coupling capacitance we have, output coupling capacitance we have, and we are adding RE for bias stabilization. But to minimize the effect of RE on the circuit, I'll be adding a parallel capacitor CE parallel to RE, and the CE is called as bypass capacitor. Okay, so when you perform AC analysis, we will be short circuiting the capacitance, right? So this RE parallel to zero, the effect of RE will be ignored. So that is the reason why we are adding this CE parallel to RE. The CE is called as bypass capacitor. Okay, and this CC is the output coupling capacitor. You have a source VS, and I'm going to take output from the collector side of my amplifier, and the load resistance is present in RL, or sometimes they call it as RC or RL, whatever it is, both are correct. Sometimes they put RC here, they connect a specific resistance here, they connect an RL here, because RL they measure V0. That is also correct. Okay, so we are going to see two things here. We are having two capacitors in the circuit. One is the RCE, which is connected parallel to RE. Another capacitor is the coupling capacitance, which is present at the input and output of my amplifiers. So I am going to see what is the effect of these capacitance on the frequency response of my amplifier. Okay, so this circuit is a fixed by a voltage divider bias, and this RE is going to contribute to the stability of my circuit. And I'm going to have a capacitor, bypass capacitor CE, which is connected parallel to RE to avoid the ohmic power loss which is going to happen across the RE. So I'm going to measure what is the voltage gain, including this CE. So I'm going to define AV as the voltage gain, and these capacitance will have effect only in the low frequency, because at high frequency these capacitance will effectively become short circuit. So at low frequency only we are going to analyze what is the effect of these capacitance on the voltage gain of the common emitter amplifier. So I'm going to define it as, usually we define voltage gain as AV. Here I'm going to define it as AVLF. LF indicates my low frequency. So AVLF is defined as, voltage gain is output voltage by input voltage. So AVLF equal to V naught by Vs. So this is the expression for output voltage gain of the common emitter amplifier. Now we are going to derive what is V naught, what is Vs, substitute in this equation and find the ratio, and we are going to find what is the voltage gain in the low frequency region. So for any circuit is given, we'll be drawing the AC equivalent circuit, and then we'll be drawing the H parameter equivalent circuit. Okay, the AC equivalent circuit means I'll be short circuiting all the capacitance and the voltage source. So the CC will not be there. The CC will be short circuited. This CC will be short circuited. This CE will be short circuited, and you have a resistance parallel to short circuit. So always current will prefer the least resistant path. So RE parallel to 0. So effectively this resistance will also become short circuited. So even though in circuit diagram you have RE, when you draw the H parameter model and you draw the AC equivalent circuit, this RE will not be coming in the circuit because it is short circuited by this capacitance CE. So in the next diagram you see, this is the equivalent circuit we are drawing. So VSRS you have HIE, HFE, IB, and this is RE parallel to CE. So since usually I told you this RE and CE will be short circuited, but since we are going to study the effect of CE, CE will not short circuit. We'll have RE parallel to CE, and only the CCV will short circuit. So whichever capacitance I'm going to analyze, I have to have that in the circuit for analysis, right? So I'm going to analyze the effect of CE on the low frequency response. So I cannot circuit CE. This RE will not come. I told that this RE will not come, but you can ask how this RE is coming in the diagram. Okay, RE parallel to CE will come in the diagram because we are going to study the effect of this CE on the low frequency response of my amplifier.